Okay, this is the last video I'm making for this, so you only have to watch three of them, I guess. We finished the last video talking about the nth term test for divergence. If the limit of the sequence is unequal to 0, then the series diverges. I just wanted to quickly go through a few examples so we can see how this works. So suppose we have, let's see, for example 1, we have the series 2 to the n. Does that converge or diverge? I would point out, and again, this should be fairly obvious, that's why we're doing it. 2 to the n, if we round out the terms, we get 2, well that's 2 plus 4 plus 8 plus 16, etc. Clearly that will be infinity. The test here says if the limit of the sequence is unequal to 0, if I look at the sequence a sub n equals 2 to the n, what's the limit of that sequence? And in this case, clearly the limit of the sequence is infinity. Since the limit of the sequence is unequal to 0, then the series diverges, which we know just by looking at it. But again, the point here is, the way the math works is, I can't just look at this and say, oh yeah, it gets really big so it diverges and I'm done. We have to write our math formally, and mathematically, I need a way to say, mathematically, this series diverges. Then I'm going to use the test for divergence by looking at the sequence. I know rules for sequences. The limit as n approaches infinity of this is really easy to calculate. It's infinity, so the limit of the sequence is infinity, so this diverges. I know that might seem slightly like I'm doing too much work, but we mentioned in class we have to be formal with our math, and we have to know what we're talking about: continuous functions, discrete functions, sequences, series, and apply rules correctly. You can't apply a rule for sequences for series. You can't apply a rule for a continuous function to a discrete function. You need tricks to go back and forth between them. That's what this lets us do. I work with series by looking at the sequence because I know how to work with sequences. So, next example. I keep writing summation notation as opposed to just a capital E. Which one do we have? N factorial over 2n factorial plus 1. I am kind of assuming here that all of you know what the factorial notation is right there. As far as it goes, if you don't, really quickly, n factorial, we'll stop instead of using n. Say we have 3 factorial. 3 factorial is 3 times 2 times 1, which is 6. 5 factorial is 5 times 4 times 3 times 2 times 1, which is 120. So to use any factorial, you just multiply all the integers from whatever you're talking about down to 1 together. It gets really big really fast. 6 factorial is 720, 7 factorial is 5040, and so on. These get big really, really quickly. N factorial then is just the product of n times n minus 1 times n minus 2 times n minus 3 all the way down to 1. The problem is, I have to write my series notation right here, just so we have it official. N equals 1 to infinity. The problem is, well, I don't know how those factorials affect the series right there. I mean, yes, this gets really big really fast, but so does that. And does that somehow cancel out, or does it not, or what? And we never used factorials in any of our calculus, because they don't really work that way, which means all of our calculus doesn't employ factorials. So do we think it converges or diverges or what? Well, one trick we can use is, I can look at the sequence. If this is the series, I can look at the sequence a sub n, which is n factorial over 2n factorial plus 1. Now, it's a sequence, and let's see, to determine whether the sequence converges or diverges or what it converges to, we can use the trick that you use for limits that you also use in calculus when you have polynomials and things like that. Divide by the highest power. In this case, divide everything by n factorial. So we'll divide an n factorial there, an n factorial there, and an n factorial there. On the top, then, those cancel. I get 1. The n factorials cancel here. I get 2 plus 1 over n factorial. Now, if I take the limit as n approaches infinity of the sequence here, as n approaches infinity, 1 over n factorial clearly approaches 0, which means this approaches 1/2. And again, I can't work with the series. I don't know any trick that works with the series, but if I look at the sequence, I can apply some algebra tricks that I know. Then I can find the limit of the sequence. The limit of the sequence is now 1/2, which is unequal to 0. Then I can say, since the limit of the sequence is unequal to 0, I can conclude that this series diverges. So it's clearly getting smaller, and the bottom gets really big really fast because it's 2n factorial, but apparently it doesn't get small enough fast enough because the series still diverges and adds up to infinity. It's good stuff. I like that. One thing I'll point out, I'm going to do one more example, but ultimately, like I said, in the same way that you learn power rule, product rule, quotient rule, trigonometric substitution, partial fraction, decomposition, you name it, with practice, you begin to identify, as soon as you look at a function or an integral, oh, this is what that function, integral, whatever is, so this is the trick I'll apply. Same idea here. We're going to have like 5, 6, 10 tests to determine convergence or divergence. It is beneficial to be able to look at what the series that you're working on and say, okay, which rule should I apply? In the same way that you don't want to have to try 7 different trigonometric 7 different integration tricks to solve an integral if you don't have to. You don't want to have to run through 7 different tests if one of them would have worked fine. As far as it goes, this is a test for divergence. So if you look at something and say, I'm pretty sure it diverges, oh, then go with the divergence test. Because then it should be solvable in like 2 steps. Look at the sequence and done. If you're unsure, well then yeah, try the divergence test. If you get the limit, if you think it's something you can take the limit of, take the limit. If it's unequal to 0, you're done. Divergence. So, one more example. Going back to the one we keep on mentioning, the harmonic series, 1 over n. I want to know if that converges or diverges, so I want to apply the nth term test. So I look at the sequence, a sub n equals 1 over n. Take the limit of that. The limit is really easy to calculate. It's not a big deal. The limit is clearly 0. So if the limit of the sequence is 0, then let's see. If the limit is unequal to 0, then the series diverges. Which means if the limit is equal to 0, what does that say? And here's the trick. That does not mean this converges. I mentioned this in the last video, and it's really important. The fact that this limit of the sequence is 0 simply means I can't use this test at all. It doesn't apply. The test only works if this is true, and if that's true, it leads to that. If that fails, the whole test fails, it doesn't even work anymore. You have to try a different test, which means here, the limit is equal to 0, which makes that not true. Test fails, so it's inconclusive. Which means I still don't actually know if that thing converges or diverges. We need other tests to do that. We're going to do those next time, which I guess will be Monday probably in class. Pretty much all of the tests we do will have conditions like this, where essentially, if this is true, then you get this conclusion, but then there'll be instances where you get inconclusive. So we have to make sure we know the tests, we understand what needs to be true for the test to work, and then we draw the correct conclusion, where sometimes the correct conclusion is it's inconclusive, the test didn't work. So I'm harping on that a lot right now, because it's going to be true for the entirety of this chapter and all the tests we do, and I want to make sure it's clear. We have to know the statement of the test correctly. You're going to have to state them on your exam as you use the tests. And then you have to say, this condition was met, so this conclusion works. This condition was not met, the test doesn't work, try a different test.